So at the Te Mihi station that was built as an improvement and eventual replacement of Wairākei, even though it is a renewable source of energy, it does come with its own complications to the environment. For example, by the 1980s, extracting the geothermal fluid had resulted in very quantifiable changes in the geothermal system there in the Taupo Valley. The geothermal system's pressure had dropped considerably. This allowed cooler water to enter the underground resource, which of course then lowers the entire temperature, which then decreases the efficiency of using hot water to power the plant. This is pretty common with geothermal energy, even though they are a renewable resource and it doesn't use any fuel and it doesn't produce significant emissions. It does eventually have downgraded geothermal fields, although none have ever been completely exhausted, and if they are maintained properly and sustainable development is kept in mind, that they are possible to maintain for a while. One of the other advantages that geothermal energy has over other energy sources is that it tends to be independent of weather and climate change. One of the great things about geothermal energy is its reliability. It tends to be relatively low cost, and this has been really helpful to New Zealand because of their growing demand for electricity. Geothermal power stations typically have load factors of 95%. Now, when you compare this to the typical load factors of 30 to 50% for hydro and wind power stations, clearly it's much higher. The Wairākei power station has operated at a load factor of over 90% for over 40 years with fairly low operating costs. For geothermal power plants, the problem in cost is not the annual cost, it is the initial or capital investment of all the equipment. Sulfuric acid dosing at the Te Mihi station is used to control the pH of the geothermal fluid and help take control of the silica scaling or residue in the pipelines, the reinjection wells, and also some of the formations in the reservoir. In case of pH control equipment failure, the station can be temporarily raised to 2 bars of pressure to lower the silica saturation index. This was a new technology that they used at Te Mihi that was not present at Wairākei. Because of the use of the sulfuric acid, they have to use stainless steel for all the wetted parts due to the possible acid pH dosing corrosion. The majority of the barriers to continual development of geothermal energy in New Zealand isn't technical or financial, but tends to be the regulations that go into monitoring the plant. For example, the plant has to obtain environmental consents or permits for various things, such as the amount of water reinjected into the boundaries of the Wairākei to Howrah geothermal system, how much is discharged by irrigation, septic tanks, air, etc. Once Te Mihi is fully operational, the concentrations of hydrogen sulfide and mercury in the Wairākei cooling water discharges into the Waikato River will decrease to fairly negligible levels. And this was part of the plan due to the environmental consents. And one of the reasons that Wairākei no longer discharges as much into the Waikato River because the concentrations of hydrogen sulfide and mercury were found to be too high. There was also a significant heat increase or discharge into the river that will also decrease or go away as Wairaki is eventually phased out as a power station. However, there are still some environmental concerns with geothermal plants in general. For example, since they tend to be situated on sites of high geological activity, the sites already have a natural higher level of earthquake risk. And there is evidence that hydrothermal plants, for example, can lead to even greater earthquake frequency. This hasn't yet been determined for geothermal. Geothermal fluids contain dissolved gases which are released into the atmosphere. Now, mainly, these gases are hydrogen sulfide, as previously mentioned, and carbon dioxide. Now, both of these are denser than air, and they can collect in lower areas such as depressions or confined spaces, and they're known as non-compressible gases. These are a recognized hazard for workers at geothermal stations and can lead to hydrogen sulfide poisoning, frequently in motel rooms or hot pool enclosures, for example, in Rotorua. Also, as previously discussed, the geothermal fluid contains elevated levels of arsenic, mercury, lithium, and boron due to the underground contact between the hot geothermal steam and water and rocks. Now, when this waste from the plant is discharged into rivers or lakes instead of being reinjected into the geothermal system, these pollutants can damage or affect aquatic life and the rest of the surrounding environment. And it can even make the water unsafe for drinking or irrigation. This was also noted in the Waikato River by the World Health Organization with the arsenic pollution, and it has almost always exceeded it by 0.01 parts per million.